Welcome to the next session on Introduction to AI and ML using Python.
Now, few things which I wanted to discuss before going ahead. I want in SVM you guys to come up with the significance of gamma and kurtosis. I will only explain now. Okay, now let's assume that what is kurtosis try to tell us. Okay, now let's take that we are studying the height of a different individuals in India. Let's take India as a country where we are looking for height. Okay, so it was pending from long time. So I just thought I'll clear this first. What is kurtosis? Okay, now let's say that this is 3, this is 4, this is 5, this is 6, and this is 7. Let's assume that. Okay, now in India, if we notice, and okay, let's take 8 also here. Okay, and we are studying for the country India with the individuals of age, say 15 years to 35 years. Okay, now if I draw the frequency curve here, you would notice that at the height of 3 we will have very less people, very less, right? At the height of 4 also we will have very less people. But there will be a lot of people who will be near to the height of 5.5 in India, right? So let's assume this is a distribution in our case. Okay, now if I want to draw a distribution over this itself, if I want to draw a distribution of Americans, so how will this distribution look like? There will be very less people with height 5 if I'm not wrong. There will be a lot of people with height near to 6 feet, right? So this is negative skewed for Americans. If you look into this with this chart, if you look into this, the long tail is on the left side, right? But if you look for the India, it looks like a symmetrical one with this graph. But what happens now is, how to understand the kurtosis behavior here is, let's say that I am looking for the salary now. Okay, let's say if I want to draw a salary chart here, salary distribution. So in our India, if you notice, let's say that there are a lot of people who are actually at the mean, okay, somewhere here, 5 to 6 lakhs. So let's say this is a perfect normal distribution. Now, as kurtosis tells the measure of peakness, this one would be negative kurtosis. Okay, and then if I want to draw a distribution over this, let's say that for a developed country, let's imagine that for a developed country, if I'm trying to draw a chart on this for the salary distribution, or not a developed country, let's say underdeveloped country. So then what happens? Okay, so far so good, right? So this is normal distribution. This is negative skewed. Okay. Now let's take an example where we have people very less in the vicinity of mean also. Let's take in some country where we have the salaries, there are very less people which are in the vicinity of the mean. So for us the mean is somewhere around 5 to 6, right? So if I'm taking a salary distribution for that, okay, now if I notice, this would be called as positive kurtosis. Okay, now there are different examples which we can always take here. Again, if I want to take an example, let's say the countries where we have highly paid opportunities, then the graph would be again negative skewed. That means there will be a lot of people who will be earning in the vicinity of 7 to 8 lakhs. Okay, now the point is why kurtosis has different formulas. So I have also looked into different articles and found that people have actually written the formula for kurtosis in a different way. So observations minus mean divided by sigma whole power 4 expected value of this, okay, minus, this is the right formula, right? If I'm not wrong, expected value of x minus mu by sigma whole power 4 minus 3. Okay, so what people generally do, there are different people has a different terminology for calling kurtosis. They generally call this as absolute kurtosis. Okay, there are a lot of people in world who call this formula as absolute kurtosis, and they call this as relative kurtosis. Okay, the reason why it is called as relative kurtosis because the absolute kurtosis value, it cannot be less than 0. As you can see, it is a power of 4, it cannot be less than 0, right? It is quite simple. Now if you want to take a perfectly normal distribution curve, you can take it some data, and if you take a perfect normal distribution, you would notice the kurtosis value, absolute kurtosis value for absolute normal distribution would be equal to 3. You can try to calculate that, and this we generally use for comparison, and then we substitute that value here. So we generally do that -3. So that's the reason people call this relative kurtosis, but I generally call this as a normal kurtosis formula. Okay, but then it doesn't matter if you call it as absolute kurtosis or relative kurtosis. What importance is, if the kurtosis value is negative, that means the measure of peakedness or the peak would be below normal distribution. For the positive ones, the peak would be above normal distribution. Okay, so that is one thing which we should understand for kurtosis, because kurtosis tells us the measure of peakedness. Okay, and now it's pretty clear that, for example, if I draw normal distribution, let's say this is normal distribution. Okay, let's say that this is normal distribution. Now it's clear that this is leptokurtic, right? Positive skew kurtosis. This is platykurtic, negative kurtosis. So when we have positive kurtosis, the thickness of the peak would be very small in comparison to normal distribution. But here in platykurtic, the thickness would be more in comparison with normal distribution. What does that mean is, lot of data will be in the vicinity of their mean. Okay, in platykurtic. In leptokurtic, there will be very less data in the vicinity of the mean. Okay, making sense? Now if I'm not wrong, there was some more points which I wanted to discuss. The other one was, what would be the final result in k-fold cross validation? Did you identify the solution for this, guys? So do one thing, because it is very interesting. I want you guys to work on it and tell me the solution in next session. Okay, this and gamma, significance of gamma in SVM. Now the last one is coding challenge. So let's discuss this before we go into the next session, because I want you to work on this. When you work on this coding challenges, you will get familiar more with Python. For example, if I have some data like this, and now you want to find the second maximum number here. Now you have to keep comparing your numbers. For example, if you think that I will use the maximum function and then take the maximum of this series, which is 27, and then I will remove 27 from the series, and then I will find the maximum again, then what you are trying to do is you are using this maximum function 2 times. And this maximum function, how does it work at the back end? It will use a for loop, and then it will compare 2 numbers at a time. So what does that mean is, you are actually trying to, for one maximum function, if you notice, you are trying to compare the numbers how many times. You have to keep comparing your numbers, and then you have to find the maximum number for every 2 numbers. So what I'm trying to tell here is, in short, at the back end, you are running the same operation many times. But if you want to optimize your code, you should think in this way. First, try to compare these 2 numbers. The bigger number would be max. The smaller number would be second max. Okay. And then you have to compare with the new number which is coming in with the max and then second max. Okay. If you try to do in this way, you will notice that the number of operations which you are working would be quite less, and that would optimize your result, the code. So please try to do in this way, So you have to assign the maximum. So every time you are comparing, the number which is max, that assign that number to say max variable, and the second max number to second max variable. Let's assume that you have a variable with 2nd underscores max and max. But in general, you should not assign the variables in this way because we already have a function max, right? So you can just say highest and then second highest. So you can assign this kind of variables in Python, and then you can do this coding, and then you can have for loops, and then you can find the second highest number in this series. So in this way, you are trying to optimize the number of for loops which you are running here. Okay. So what happens? For example, if you have a number 3 here before 7, then this 3 would be compared directly with the smallest number of these two, and then we know that 3 is nowhere in the scope for second maximum. So we don't have to compare this 3 with 10 now. So these kind of things we have to think for. Okay. So we have to analyze a lot of things, and then we have to write this code. I have already given you the logic. Now try to write this code to identify the second maximum number. Okay. So you will find it very interesting. Okay. So before going into the next session, let's revise what we have learned in the earlier sessions. Okay. So in the earlier sessions, we have looked into regression for predictions, and then we have looked into classification algorithms, which can also be used for prediction, but I am not teaching that in the session because in general, these algorithms will be used for classification. But of course, you can learn the logic how to use this for prediction as well. Okay. So the last session, if I'm not wrong, we have completed k nearest neighbor, and I told you that that was the simple most algorithm, so that you can write your own KNN algorithm in Python using for loops or if else. So you can write your own algorithms. It is always important when you write the code from the scratch, you will understand the coding in a better way, and then you will also understand the machine learning concept in a more depth. You will get a lot of doubts, and you will get a lot of questions in your mind, for which you will explore a lot of things, and while exploring you will learn a lot of things. So it's important that try to write the code from the scratch. If the algorithm is very simple, I recommend you to write the code from the scratch. If not, you can always use the functions in Python which are already there for scalar. Great. Okay, in this 9th week, we were supposed to discuss artificial neural network, but I am planning to keep this at the end now because this is quite complicated, and the next course would be continuation of this. So I have a plan to keep it at the end, because once we complete with this course, the next course will start from this. So let's go to week 11 now. So remember this, this is our 9th session, and we are starting with k-means. Okay. So this is slightly different from supervised learning. Okay. The first thing which you need to understand the difference between supervised learning and unsupervised learning is, see, it's very simple. Let's assume that there is a small baby at your home. You are trying to train them, okay, not to touch the fire, not to touch the hot things, okay, and you're not supposed to eat this, you're supposed to eat this. So now you're training the baby, right? So that is something related to supervised learning. You're supervising your baby, right? But when it comes to unsupervised learning, it's something like you're not supervising it. Okay, now the baby has grown up, he will learn things by itself. Okay, or he already know what needs to be done. He will try to identify the patterns in his learning phase. He have already find the patterns in that. So there is no training, I would say not training phase, but there is no supervision here. Okay, there is no supervision in the sense, how would be the data look like now? In the supervised learning, the data was always supervised by output data, right? X1, X2, X3, so on, and then you will have output variable which is Y. But in unsupervised learning, there is no such supervision here, so there is no output variable Y. It's everything about X1, X2, X3, X4, so on. Okay. Now, for example, let's take in this way. I'm just giving some examples. I'm not sure about the values, but just consider this some examples. Okay, let's assume that you have this kind of data and now you are trying to identify there is no output here. Okay, the output is not like there is no explicitly mentioned output here, such as y, which we used to do in supervised learning. What we are trying to do here is we are trying to identify the patterns. Okay, just think in this way. In this case, if you notice, these are some data which are very close to each other. These are the data which are very close to each other. Okay, whenever there is a data which will be here, we can identify that these kind of data are very similar, these kind of data are very similar. And then, for example, these are the data of the dimensions of different components of a vehicle. Then I can understand that, like the domain knowledge what I have with respect to automobiles, I can tell that this looks something similar to brake disc. That this could be the radius of the brake disc, and this could be the thickness of the brake disc, and then this could be the volume, for example. But this doesn't look like a radius of a brake disc. What could this be? I'm just giving an example. This could be the length of heat exchangers, this could be the thickness of heat exchangers, and this could be the volume of heat exchangers in the car, right? So what we are trying to do is, by looking at the data, we are trying to identify the patterns. Okay, and how we are trying to identify the patterns here is by based on their similarity. Okay, so this is one example. What we are trying to do here is we are trying to find the patterns here. Okay, there is no such output y here. So this is one example. The other example, for example, I'm not sure, but if you have noticed in Amazon, whenever you try to buy a mobile, they always try to tell you that people who have bought the mobile, they have also bought this kind of earphones, this kind of chargers, or something like that. Have you ever noticed it, guys? Right. So this kind of things are called as recommendation system. Okay, the example which I've given, and this example what I'm given, these are called as clustering, that we are trying to make a subgroups of it using similarity between the data. Here we are trying to find the pattern, here also we are trying to find the pattern. So by looking at the pattern, we are trying to use this data, and then we are trying to do our analysis. So this unsupervised learning has different kind of problems. One is clustering, the other one is recommendation system. The other one could be, just think in this direction, like if you notice, whenever you go to grocery store, you must have noticed that bread is always kept near to milk. Bread is kept near to the milk, or jam is kept near to the bread, or what else can I come with?